Geometric series. Verify each series is geometric in the lesson opener, and then find the sum. Each series does have a common ratio, and the sums are given. Check your work. To find the sum of a finite geometric series, we have a formula. S sub n equals a sub 1 times 1 minus r to the n, all divided by 1 minus r, where a sub 1 is the first term, and r is our common ratio, and n is the number of terms. Practice using the formula. Find the sum for this first example. Do you have the sum yet? Be really careful, especially if you're using a calculator here. Hug that whole numerator and hug that denominator. Here the sum is 1,275. Now given a geometric series, let's see if we can find the sum. First thing we need to ask ourselves is, what do we know? I know in the formula I need a sub 1, r, and n. Do I know all three of those things? Here I know the first term is 3. I also can find r, term divided by previous term, which is 2, but I don't have n. I have the last term, but I don't know how many terms there are altogether. So how do I find n? What do we use when we're missing something in our formula? The explicit definition. I know the explicit definition is a sub n equals a sub 1 times r to the n minus 1. If I plug in what I know, a sub n is my last term, 3,072. I know the starting term is 3 times 2, that common ratio, to the power of n minus 1. What will I do here to start solving for n? Well, I better get rid of that 3. Now I have 1,024 equals 2 to the n minus 1 power. Ooh, what I'm solving for is in the exponent right now. So I really need to make the two sides of my equation look alike. 1,024. Is there any way I could make 1,024 look like 2 to some power so I could match my bases? 1,024 is 2 to the 10th power. So if I know 2 to the 10th equals 2 to the n minus 1, I have a common base so I can focus on my exponents. 10 equals n minus 1. Well, hey, add 1, I'm going to get n equals 11. Now that I have all the pieces of my formula, take a moment to plug them in and find the sum. S sub 11 is 6,141. Looking at this next one, we have summation notation. Our lower limit is n equals 0 and our upper limit is 20. So how many terms are we going to have altogether? 21 terms. Oh, I really hope I can use my formula here. Is this arithmetic? Does it look linear? No. Geometric? It definitely looks geometric because I can match it up with that a times r to the n power, that geometric model. Now we know n equals 21. R, if I match it up with that model, is 1/2 because it's the base. And hey, what's my first term here? If my lower limit is 0, that means my first term is a sub 0 instead of a sub 1. So I could plug in 0 for n. 4 times 1/2 to the 0 power. 1/2 to the 0 power is 1. 4 times 1 is 4. Okay, find the sum. It comes out to 7.999, so we'll just say about 8. Notice you could have written your r as 1/2 or as 0.5.
Sum of an infinite geometric series. That sounds impossible. In arithmetic, we couldn't add up a series that went on forever, but with geometric series, we can sometimes. So let's learn a couple of new words. An infinite geometric series is said to converge if, as n increases, a sub n decreases. What does that mean? It simply means as the number of terms increase, we notice that the value is decreasing. So let's check for our common ratio. Well, term divided by previous term, checking both, we see that r is 1/2. Do you have a conjecture as to when infinite geometric series will converge, get smaller? Yes, anytime the common ratio is less than 1, but more specifically when the absolute value of the common ratio is less than 1. An infinite geometric series is said to diverge if, as n increases, a sub n also increases. So once again, what does that mean? That means as the number of terms increase, we see that the value is also increasing. What's our common ratio here? Term divided by previous term. Our common ratio is 1.2. What's your conjecture about an infinite geometric series that diverges? Yes, anytime the common ratio is greater than 1. Let's take a moment and just think about this. A series converging. Well, we said that's when r is less than 1. That means that the numbers are getting smaller and smaller and smaller, really approaching 0. So it kind of makes sense that we would be able to add that up. What about diverging? The numbers are getting bigger and bigger and bigger. There's no way we could add all of that up. It's just growing without bound, like infinity. It's important that we can determine whether or not an infinite series will converge or diverge. Try the next two. Find the common ratio. Okay, on the first one, term divided by previous term, and I checked all of them, r equals -4. Well, the absolute value of -4 is 4, which is greater than 1. So the first series diverges. The second example, term divided by previous term, the common ratio is -1/7. Absolute value of -1/7 is 1/7, which is less than 1. Therefore, it converges. You might be asking, why do we care? Well, if the infinite geometric series converges, we have a formula to find its sum. S equals a sub 1 divided by 1 minus r. The first term divided by 1 minus the common ratio. Let's try it. The first series is presented in summation notation. Is it geometric? Are we seeing that form a times r to the n? Yes. So if we can find the sum, we'll need the first term, which in this case is actually a sub 0. I plug in 0 for n, and I get 2/3. R, that common ratio, is the part being raised to the n. The common ratio is 5/4. Absolute value of 5/4 is greater than 1. What does that mean? It means it diverges. It keeps getting bigger and bigger, grows without bound. I continually add a larger and larger and larger number. We can simply say it diverges, therefore not possible. Let's take a look at our next series. The common ratio, term divided by previous term, 1/4 divided by 1/2. That's going to be 1/2. Common ratio is 1/2. 1/2 is less than 1. This converges. We can use our sum. So our first term is 1. The common ratio is 1/2. Plugging into the formula, S equals first term 1 divided by 1 minus the common ratio. 1 minus 1/2 is 1/2. And then 1 divided by 1/2 is 1 times the reciprocal, 2/1. The sum of this series is 2. Practice your skills. See if you can get the next two examples. In the first series, the common ratio is 1/3, which is less than 1. Therefore, it converges and we can find the sum. The sum is 3/2. In the second series, the common ratio is 2. Therefore, it diverges and the sum is not possible.